Hey everybody, I'm Ozzy from Three Monkey Solderless, and today we're going to look at this, which is the load box that we were using for all of the slaving experiments that we were doing. So some people had asked about the construction of one of these and the design of one of these. So today we're going to go ahead and open one up and draw out the circuit and see what's going on with it. So if you're interested in doing something like that, stick around. Okay, so we're down at the table and I've got the load box. I'm going to remove the cover to expose the internals. And what I'm going to do is I'm going to draw, we're going to talk about the design and the construction, and I'm going to do a layout of the circuits inside the box for you. I think a layout is better than a schematic for our purposes, as not everybody can read a schematic, but those who can read a schematic can definitely read a layout. I should also say, if you can't read a schematic, maybe you should get a little bit more electronics experience under your belt before really delving into things like loads for tube amplifiers for expensive equipment, where there's the potential of damaging your equipment through simple mistakes or faulty designs. Now, having said that, I would also like to give a little bit of a disclaimer regarding load boxes, and particularly this load box. This load box is not the only way to build something. It's what I built for myself to use by myself. I wouldn't recommend necessarily using one of these pieces of equipment with your expensive tube amplifier, as the potential for damaging that amplifier definitely exists. They're known as transformer toasters for a reason. I developed a circuit that's not too far off from what a lot of people have used. This is not a unique design by any stretch of the imagination. But when you're considering building something and considering a design, you always have to weigh the benefits with the downsides. Decide what risks you're willing to accept, and what risks you're not willing to accept, what you prefer the thing to do, and whether the risks outweigh the benefits. That's a decision for you to make. As well as there'd be other decisions about, what theories you subscribe to regarding what are the downsides and how to mitigate those. What would be the impedance of the load box to match your amplifier that would make it run safer. There's a lot of arguments to go in different directions, and that would be a decision for you to make. This is by no means the definitive load box. It's something that I've used, has worked for me. I haven't damaged any of my equipment with it yet. But then again, that is my equipment, and every amplifier is going to react a little differently when being hooked up to one of these things, and that is dependent upon its design, its construction, and how the amplifier was set up. What's its wattage? Was it built well? How good are the tubes right now? Is the transformer well built? Has it got a lot of wear on it already? What is the load box properly constructed? These are all things that you are going to have to decide before utilizing this, because the potential for damage does exist. All right, so that being said, let's get into what this thing is. Basically, it's two circuits, so to speak, in one. You have the load, and then you have the line out. These two things can exist separately from one another, but in my case, I decided to put it all into one box for convenience sake, because really only has one purpose for me, which is to run my tube amplifier into another amplifier, be it a power amplifier or another Marshall, or run it into effects, something along the lines of a rack effects system. Okay, so it's worked well for me in that regards. The construction of the box is a large aluminum Hammond box. And the reason for choosing aluminum is that it's great at dissipating heat, which is what this thing is going to be creating a lot of. There's a reason why they called them a hot plate as well, not just a trainee toaster. What the load is going to do is going to substitute for the speakers that would normally be connected to your output transformer of your amplifier, and it's going to take those, present a load to that output transformer, which will then be reflected back to the tubes in the amplifier to create the load for those, and then it's going to take the energy produced by that transformer and convert it into heat. Okay, so that being the case, what I prefer to use are these large aluminum resistors, right? Which are directly mounted to this aluminum chassis. So this chassis gets hot, but being that it's aluminum, it's able to dissipate it quite nicely. You can also attach, let's say, some aluminum fins to the back as well if you wanted to keep it even cooler. But so far, so good with this. The resistors I'm using, and it was a surprise when I opened this up again this morning that I had forgotten that I was going to order 2 more of these resistors, but never got around to it. I had substituted 4 of a different wattage for this circuit. But basically, I've got these Arcol 100 ohm, 100 watt aluminum fin resistors, and these are available from like Allied Electronics or Mauser. You can probably find them on eBay. But basically, you want a nice quality. Arcol are good, Dale are great. I can recommend those 2. And then you're going to wire these up in a way to end up with the final impedance that you want your output transformer to see. In my case, it's 25 ohms. So I've got 2 100 ones right, 200 ohm right here, and then I've got 4 200 ohms. So these 4 together create 100 ohms at 100 watts, and then I've got these 2 at 100 ohms creating 50 ohms. So we end up with 25 ohms with a rating of around 300 watts. Now I would recommend going 2 or 3 times the wattage rating of the amplifier that you're going to be hooking it up to. So in this case, I'm going to show you what I would have done had I had more of these Arcols, which would have given us a 400 watt rating of resistors and 25 ohms impedance. Now I like to go in a mismatch in the upward direction. I feel that limits some of the stress on the output transformer. There are those that would argue that it promotes flyback to the transformer. I can't argue with that, but in my case, weighing the cost benefit, so to speak, I chose to go in this direction with the upward mismatch, and I used my Marshall set on 16 ohms plugged into this, which is at 25 ohms, and it served me well. It may not serve you well, so please be careful in selecting your components and doing some research to be sure that you know what you're getting into and that you accept the risks. So let's go on with drawing this thing out for you and the circuit itself. So let's start off with the load circuit. The load circuit is comprised of just a few parts. We have these 2 jacks right here. You really only need 1. And then these resistors. And that is all your load is basically resistors taking the place of speakers, right? All right, so I'm going to go ahead and draw these in. I have 2 jacks here just basically in parallel so I can get a, a utility sort of expansion, so to speak. So they're switchcraft jacks. So you have your ring, rather your sleeve and your tip. Okay, so this is your tip, and these right here are your sleeves. Now your sleeve is connected to the chassis, grounded to the chassis. There's some tooth washers there to help create that connection. I recommend using those as well. They create a good electromechanical connection to the chassis itself to create a good solid ground. And then in my case, these 2 tips are connected together, so I have like a little bit of expansion out if I want to run it into, something else, like a speaker cabinet or God knows what I would think of. All right, so we've got the 2 jacks, right? These are your ins, real quick. And then you're going to have, and I'm going to draw it the way I would prefer it, with 4 100 ohm, 100 watt aluminum resistors. So I'm going to go ahead and draw those in, okay? Here we go, resistors. And these are all connected in parallel, okay? It's a lot of mishmash wiring in there, but they're all in parallel, right? So we got 100 ohm, 100 ohm, 100 ohm, and 100 ohm for a total of 25 ohms, right? Because they're in parallel, they're divided in that case, so 4 into 125. A little sip of the purple drink. All right, so how are they connected? You've got one side connected to the tip connection on your switchcraft and the other side connected to your ground. All right, So you basically have, just like in anything else on a speaker, one terminal of the speaker goes to the tip, the other terminal goes to the ground. Done. That is the sum entirety of the load section of this unit, and that's all you need for a load box. Now for the line out, the variable line out, there are 3 more components. We have a potentiometer, we have a transformer, and a plastic jack for ground isolation. So let's go ahead and we're going to draw those in. First, let's draw in our transformer. Okay, so I'm going to draw that guy in here. And this is a capsule sort of transformer. It has a little bit of a capture ring on it, right? As you can see, mounting hardware similar to a can clamp. And that is mounted directly to the chassis. So in a sense, the case of the transformer is in fact grounded at chassis ground. So we'll draw that in, all right? Now, I should also note that I put a little tag strip on there. That doesn't come with the transformer. It's just a little 1, 2, 3, 4, 5 tag strip. And it is screwed directly to this little tab that is mounted on your capsulated transformer. And that creates this terminal as a chassis or case ground as well. So I'm going to mark that in as the case ground. All right, right here, and that is at chassis ground. All right, and now this transformer here, I'm going to give you the number of it. It's a Jensen. It's a 6110K. All right, Jensen. And I don't even know if they make that anymore. I know you could probably still get the Jensen transformers, like on eBay or somewhere else. They make a lot of these things, and they never really are completely unobtainium, or won't be for a long time. But if you go to Jensen, you can buy them from them. I think they even have another transformer now that they're recommending for this application, as well as some schematics for utilization as a line out or a line matching for a tube amplifier. I don't know if it's variable or not in the schematics that they give, but you could check that out as well too when you weigh whether you want to do this and how to design it, or whether you want to copy this or not copy this. But as I said, that's up to you. Now the transformer itself is well, actually we got to put in the other parts. I'm going to put in let's put the potentiometer just over here, just to make things all nice and easy. And there's our knob, right? And then our out jack, right here, which is plastic out, and it has our little tabs on there, connection tabs. All right, so we have our resistive trace, our wiper, and this is a 250K pot, 250K, which was in the ballpark of what I wanted to use. Other guys have decided to use different lower or higher value potentiometers depending upon the load they want to present to the secondary of the transformer, which could result in how the transformer itself sounds and how it performs. 250K is what I settled on, and I'm happy with that, so that's cool. Yeah, so let's keep going. Now the transformer is divided into 2 parts, right? We have a primary side and we have a secondary side. So we've got our primary over here and our secondary over here. And if you look, I'll show you, I don't know if you can see in there too good, but let's turn it around this way. In there are 2 little sort of round holes in the transformer, to which some wires come out. This side being the primary side, this side being the secondary side. All right? Now the primary side, let's draw all this out for you, has 2 wires on it, a green and a black. Now in this case, the green wire is for the tip connection, and the black wire is for, no, excuse me, I have it backwards. The black wire is for the tip, green is for the ground. Now you can flip that as well. You can put it, if you want to change that around, that's fine to do as well. That will give you a different phase for the unit, and you can even put in a switch in there if you want to flip it. That's fine. But I chose to go this way. So let's draw those in real quick. So we have one coming out here, which is going to here, and another one which is coming out, which is going to here. All right, so the tip one we said was what? Black? Was that right? Yes. So this one would be black, and this one would be green. Okay? Now some people would even advocate putting the potentiometer on the primary side. That would also change the loading aspect of the transformer as well, and can give you a little bit of a different sound as it's sort of like rotated, as your variability is changed. I'll leave that up to you as to whether you want to experiment in that regard too, about whether you want your variability on the primary or the secondary side. I went with the secondary side. All right, so let's continue. The next thing we've got is, going on to the secondary, we have right here another black wire, but it's on the secondary side, identified that way, and a white wire. Now those two are to be grounded for the way that this is to operate. So we're going to go and we're going to take this one out and put it here, and this one out and put it here, right? And this would be your white and your black. Okay? And those are grounded, and that is a chassis ground, right? So it is coupled with the ground of the load, and the ground of the case, and the ground of the chassis. Those are all coupled. Our secondary, or rather our variable line out, is going to be ground isolated, but you can also put in a switch to ground out that as well if you have a need to fuss around with your ground situation. In my case, no ground loop with the isolation for my purposes, so I didn't bother putting in the switch. So let's continue on with the secondary side. Next thing we've got are two wires that are just basically tied together and then put off into space. They're just tied together basically. So that would be an orange and a red. So let's go ahead and we'll take them right here, right? And these two are connected and they don't go anywhere. So let's say that's the red and that's the orange, O-R-G. All right, so your red and orange wires on the secondary are just tied together and taped off. All right, I used just a spot on this solder tab to tie them to solder them to create the connection between the two and keep them sort of nicely out of the way. If you don't use the solder tab option, you could just tape them off, tuck it away, make sure it just doesn't contact anything. All right, so let's continue on. Now, the wires that we've got left are the brown and the yellow. All right, so let's go ahead and put those in. First, we have the brown and the yellow. All right, so this is the brown, B-R-N, and this is the yellow. All right. Now, where are they headed to? Very simply, they're headed to the potentiometer. And the way this works, basically, is we attach the brown to one side of the trace on the pot and the yellow to the other side of the trace of the pot. These can also be reversed as a phase sort of flip if you need to flip your phase, if you're using these, let's say in a live situation and you're finding phase issues with your guitar sound versus like the bass or something else. You can add in a little switch which will flip these two, brown for yellow, yellow for brown, and allow you to flip the phase of the amplifier, or rather of the unit on the secondary side. Okay, so then we have one terminal left on the potentiometer, and that is the wiper, and that is going to be your output, right? All right, so that goes to the tip of your output jack. Now we also have, since this is a plastic jack, being that it is isolated from ground, we need to create its sort of little connection as well, and that'll come from the brown right here, right? Okay, I hope that makes sense. Basically connected to here, all right? And that would be what you would put your little ground switch on if you wanted to create a chassis ground for the secondary side. You would just put a little switch that would connect this terminal of the output jack to chassis ground. So basically that's all there is to it. It's a pretty simple little setup here. Oh, I should include what is the model of the of the case that I'm using, and it's a Hammond, right? Where's my bigger pen so you can read it? It's a Hammond. And this is available from Mauser. It's a there's my dyslexia, 50Z220. Okay, so 1550Z220. And it's a good rugged piece of construction, easy to drill, easy to work with, has a lot of metal for, being used as a heat sink. And those resistors here, will mark them down. These are Arcol. And they are 100 watt and 100 ohm. Okay? So really that's all there is to it. So if you feel like trying your hand at building one of these, you can do it. But like I said, if you hook it up to your amplifier and something goes wrong, that's on you. If it were up to me giving advice to people, I would say don't use a load box with your amp. It's kind of like similar to like a car. Putting nitrous on your car. Is that a good idea? Probably not. Is it a lot of fun? Definitely. So you decide how you want it all to work, and go ahead and build one of these if you like it. And that's really about it for today. So thanks for watching again. And I think next week we'll have another kind of special amp from the collection. Maybe even this week, a aluminum chassis, 1967 100 watt Marshall, which would be basically like the very first amps produced after the white back panel JTM 100s. It's very similar to the Hendrix amp. So look for that soon. And again, thanks for watching.